Welcome to the Max lecture series. In this series, we are solving problems which are related to integration. So in the last class, we saw there was one single integral. They have given certain limits like 0 to infinity, and they have given two different functions with the same variable e power minus y power 3 dot y power 1 by 2 into dy. We just tried with the substitution method, and we also learned one value that is called gamma of n. Gamma of n can be written as 0 to infinity t power n minus 1. See there, I have written gamma of n is equal to 0 to infinity. Here we have taken p, right? So p power n minus 1 into e power minus p into dp. That is very important, just to note it down, because most of us are not aware of some things. Because of that only we people are struggling while solving the problems in the examination. So this is the relation. So you can write, so gamma of n can be written as 0 to infinity p power n minus 1 into e power minus p into dp. We also learnt one more thing, gamma of 1 by 2 can be replaced by square root of pi. That is very important. And we also understand whenever the variables were given like this two times, we can try with the substitution method with the limits also. Now, if you observe the new question, so the question is simply there is no any limits. Simply they have given, you are requested to calculate the integration of log x into dx as the value of dash. Sir, what is the difference between previous question and this question? You might have heard this word that is called a definite integral and indefinite integral. So the meaning is, definite means certain limit will be given always. Indefinite means limit will not be given, just we have to integrate and drop your answer. If you observe, in this integration limit is not given, that is called indefinite integral. In the last question, limit has been given as 0 to infinity, that is called a definite integral. Okay sir, how can we solve this question? We know if I will differentiate log x, we will be getting 1 by x. Yes or no? That is true. If I am integrating log x, what can we get, sir? What is the differentiated value of log x? If you differentiate log x with respect to x, this will give you 1 by x. True, we can keep this one. Similarly, if we integrate 1 by x with respect to dx, we can say, sir, yes, that value is equal to log x, because they are vice versa. Differentiation will give you integration, integration will give you differentiation, vice versa. There will be no doubts between these two. But the problem here is, sir, directly they have given integration of log x. What can I do, sir? See there, whenever log x will be given in integration with respect to dx, just consider this one into two parts. How can I consider, sir? Let me tell you how can you break this one. What we have to do is, take this function and treat it, this is famous model question. You can write like this, integration of log x dot 1 into dx. You have to break this expression like this. Okay sir, once it is breaked, then how can I proceed further? Now you can easily proceed further by treating, see there, I am giving some name for this expressions. What I am going to do is, I am just calling this value is u, and see there, otherwise let me break this. You can rewrite this function like this. You can treat u is equal to log x, u is equal to log x, and v is equal to integration of 1 into dx. I am just breaking this into two parts. I am considering integration with 1 into dx, and I am treating log x equal to u. You know u formula, right? Integration of u v dx. Integration of u v dx. This integration I am considering with the v dx. Actually, how can we proceed further? What is the formula? This can be further written as u into integration of v into dx minus u dash integration of v into dx. After that, put one whole bracket, again integrate the whole function with respect to dx. That is the generalized formula, UE formula. So we are going to apply this integration formula whenever log x is given with respect to x. Of course, given limit is indefinite indefinite integral. Shall you proceed further now? It's very easy. Just apply the formula into the expression. Okay sir, u is equal to log x. Here integration of 1 into dx equal to v. Just continue that derivations from here. What you will be getting here, in place of u, see. So here in place of u we are having log x, in place of v we are having 1 into dx. First step, u will be again directly taken out. Yes, u will be again directly taken out. Integral of v into dx. In place of v, we are having what? 1 into dx. What is the integral value of 1 into dx? That will give you directly x only. Integration of dx will give you x. So I can put the value of x here, minus u dash. U dash means I have to differentiate log x. Just now we saw if we differentiate log x, we will be getting 1 by x. Yes sir. So the value of u dash will become 1 by x. See, I forgot to put the overall limit. Actually what we have to do is here, 1 minute guys, here when the moment we are putting minus now, after putting the minus, you have to put one more limit. That is one more integral, overall integral with respect to dx, right? Integration should come there. Anyway, overall integral I am keeping outside. I am doing integration. Inner part we will complete first. U dash, integral of v dx, just now we saw that is x only. And then whole integration with respect to dx. See that x will get cancelled out. Finally what will be getting? X dot log s here. Can I write like this? I am just keeping this x first. Minus integral of dx will give you x. So the correct answer for this function is, if you take x outside, it will become log x minus 1. That's all. So we successfully found the answer for this function. So what we learned in today lecture? We learned the differentiation of log x, integration of 1 by x. Of course, integration of log x also we understood now. Whenever integration of log x will be asked, you have to go with this method is called integration by parts. This is called, you might have wrote these things, this is called integration by parts method. The formula is integral of uv. Whenever integral of uv dx is given, don't forget this is very important formula, because there are so many questions by using this formula. So just make a note. In each and every lecture I will be covering what are the things that you people are missing. Because of that only you people are struggling while solving the problems which are related to integration. So I strongly believe that when you are directly observing these equations under application orientation, like while solving the problems, you can understand how we are approaching these formulas while solving, how we are approaching these formulas while solving the problems. Okay, fine. This is all for this lecture. Remaining things we will see in the next class. If you are really understanding whatever the content that I am delivering in this lecture series, just click that like button and also share it with all your friends. Thank you all.